Hi, so today we're going to learn about rationalizing the denominator. So to rationalize the denominator, we're going to basically go through an example and I'll show you how to rationalize the denominator. So for example, let's take 5 over 6 root 7. So feel free to pause the video and do this on your own, and I'll show you how to do it right now. So when we have an equation like this, we don't want to have a square root in the denominator. And we already know denominator is on the bottom and numerator is on the top. Numerator and denominator. And we never want to have a square root in the denominator. So we have to get rid of this root 7 right here. This root 7. So in order to do that, I'm going to first multiply this whole thing by root 7. So root 7 on top and root 7. So when you multiply by root 7, essentially what you're doing is just multiplying by 1. But you're multiplying the numerator and the denominator by root 7. So these two cancel out, this and this. So basically, this equation gets multiplied by 1. So we're not changing the equation, but rather we're just getting rid of this root right here. So when we do this, we get 5 root 7 over 6. And then since it's two root 7s that we're multiplying together, it's root 7 squared. And when you square a root, the square and the root just go away. They cancel out each other. So essentially you're left with 5 square root 7 over 6 times 7. And then you multiply this out and you get 5 root 7 over 42. So that's the answer. So this is how you rationalize the denominator. Essentially, what we're just doing is getting rid of the denominator that's in my bad. We're just getting rid of the square root that's in the denominator. So in this example, the root 7. So essentially, we're just multiplying the square, like whatever root it's in the denominator, the root that we're trying to get rid of, by itself, so like this, and then we'll multiply the numerator and the denominator by it, so that it's essentially, you're just multiplying 1. Just multiplying the whole equation by 1, so you're not changing the equation. Because if you multiply only the denominator by root 7, and not the numerator by root 7, then 5 and 6 root 7 and 5 root 7 over 42, these two will not be equal. So these two will not be equal together. However, if you multiply the numerator and the denominator by root 7, then I'll just say that if you multiply the numerator, only the denominator by root 7, you won't get this answer, you get something else. But I'm just showing that whatever your answer is, it won't be equal to the original equation. So you have to multiply the numerator and the denominator by root 7, or whatever root is in the equation on the denominator. So let's go through another example. So now let's do a bit more complicated one. So let's go through this one. 3 root 2 over 5 plus 4 root 5 over 2. So essentially, how you solve this, right? So feel free to pause this video and think about it, okay? So first, what we're going to do is distribute this root to 2 and 5, and this root to the 5 and 2. So we get, this is what we get, 3, and then root 2 over root 5, and then, or I can also write this as this. So 1 minute, let me write it another way. So you get 3 root 2 over root 5 plus 4 root 5 over root 2. So what you're just doing is distributing this root to the 2 and the 5. Same with here. You're left with this, right? After you're done with this, you multiply each by itself. So like you multiply it like individually. So let's take this for example. So 3 root 2 over root 5. So, and then you multiply it by root 5, for the denominator and the numerator. So root 5. So essentially you just multiply them by 1. And so when we multiply two roots, you multiply the number inside the roots. So you multiply 2 and 5. So you get 3 root 10 over these two, you just get root 5 squared. And so that is just 3 root 10 over 5. So that's the first, so this is simplified to this. So now simplify this. So 4 root 5 over root 2. You multiply the numerator and the denominator by root 2. And you're left with 4 root 10 over root 2 squared. And then you multiply it out and you get 4 root 10 over 2. As you can see here though, the 2 and the 4 cancel out. So this goes to 1, this goes to 2. So this goes 2 root 10. And now you have 3, or actually 1 minute. Let me just write it here. You have 3 root 10 over 5 plus 2 root 10. So now what you're going to do is 2 root 10 is just basically 2 root 10, and the denominator is basically just 1. But you just don't write it, but it's basically 1. So you multiply this whole thing by 5, and you get 10 root 10 over 5. If you simplify this, you get 2 root 10 again. So now you can add it together. So 3 root 10 over 5 plus 10 root 10 over 5. And it's just basic addition, fractional addition. So you just get 13 root 10 over 5. So that's our final answer. So you can take this, these two, and you can simplify it to 13 root 10 over 5. So that's what I mean by rationalizing the denominator. It can be useful for various, like lots and lots of other lessons, I'd say. And it's very useful going forward in math. And I'd say this particularly comes up in algebra, when you're taking algebra courses in high school. And yeah, that's basically what you do for rationalizing the denominator. Here, I'll give you another example. 1 minute. So, one other example. How about uh, okay, let's do this one. So let's just say we have 2 on the bottom. So like, let's go this. And so let's say this is the equation, right? And you have to, so on the bottom there's 2, so there's 2 terms, right? Because this is a minus, so there's 2 different terms. When you have 2 different terms, you can just multiply, you can't just multiply by -5. I mean, my bad, not -5, square root of 5, because then the square root would just go to 3. So you really can't cancel it out by just multiplying by root 5. Instead, I'm going to show you something else. So first, let me show you something. So let's just say this is a basically like property. So if we have root a plus root b, then we multiply it by root a minus root b, you essentially just get a minus b. I'm not going to go into the steps of that, but it's just a basic property that we're going to use here. And so let's keep this in mind, alright? Or if you want to take a screenshot, here you go. So let's just keep this in mind, alright? So now what are we going to do is, based on the other property, we're going to multiply by a conjugate pair of this term, like this equation right here. So what we're going to do is multiply by 3 plus 2 root 5. You're going to do the same for the numerator. 3 plus 2 root 5. And you would do this, like, say, example, this is a plus, then you multiply by 3 minus 2 root 5. That's what you would do. So now what we're going to do is we're just going to multiply it out. When we multiply it out, we get 6 plus 2 times 2 root 5 over, and the property that we just used is that if you multiply these, so yeah, so you get A minus B. And if you look, A minus B, so you do 3 times 3, so you get 9. And then you multiply the 2 and the 2, so it's 4. And then 4 times 5. Because if you multiply root 5 by root 5, you just get left with 5. So you multiply 4 times 5, so it's 20, right? You do minus 20. So minus 20. And now you just solve it out, basically. So you get 6 plus 4 root 5 over, so 9 minus 20, so negative 11. And so this is the final answer, so I'll just write it like this. So you can either write it like this, or you can also write it like, so like you say, yeah, 6 plus 4 root 5 over negative 11. So this is an acceptable answer. Or you can also write it as negative 6 minus 4 root 5 over 11, because some people just don't like to put the negatives in the denominator. They want the denominator to be whole and positive. Or you can also write it as negative 6 minus 4 root 5 over 11. So these will all be acceptable answers for this. So the main thing that you have to learn from this is that when you have two conjugate pairs, basically, so root A plus root B, you multiply it by root A minus root B, essentially you just get A minus B. So that's what we did here. When we multiply these two conjugate pairs, we just multiply the first term, so 3 and 3, but like you just multiply it by itself, so you get 9. And then you multiply the number in front of the square root, so it's 2, right? This 2 times this 2. It's always going to be 2 since it's a conjugate pair. And you get 4, right? And you write down 4, and then you multiply the square roots by times itself. Square root times square root, they cancel out. You're just left with the number inside the square root. So it's 4 times 5. That's how you get 20. So 20 right here. But you see this right here? When we multiply two conjugate pairs, we're left with a negative like a negative sign, A minus B. So it's not positive right here, it's a negative. So I hope you've learned what rationalizing the denominator is, and I hope I've cleared some doubts for you. If you have any other doubts, leave them in the comments, and I'll try to respond to them the quickest. Thank you for watching. Have a great day. Bye.